Tetra Pak was founded in 1951, but it grew out of a company established in 1929. It's evolved from its food carton origins to become a tech partner, helping household brands improve the efficiency of their production lines. It's still a privately owned company, and its headquarters is still here in Lund in Sweden. Johan Nielsen is the Vice President of Tetra Pak Services. He joined Tetra Pak in 1987 as a trainee service engineer. So he's seen a lot of transformation in the company. I asked Johan about Tetra Pak's business model and who its B2B customers are.
We have around 5,000 customers, or a bit more than 5,000 customers in 170 countries around the world. This is large liquid food manufacturers, dairy companies and other things such as Nestlé, all over the world, Yili in China, Meiji in Japan. We have Coca-Cola, PepsiCo, and these type of companies. And we provide the material, the laminated carton material, closures, the straws, etc., to make a juice or a milk carton. We produce all the equipment related to processing the milk and the juice, etc., and to package it and to put it into containers onto a pallet ready for retailers. And then we provide a large portfolio of services to make this an efficient operation for our customers.
One of the services Tetra Pak offers its customers is predictive maintenance.
Predictive maintenance works in a way that you have sensors in equipment. It can be vibration sensors, temperature sensors, torque sensors. Then you use that information. So we take around 600 signals from a typical production line. We collect them through the cloud to a data center we have. And then through algorithms, you calculate remainable usable lifetime. So you see how vibration increases. And then you know that when vibration in combination with a certain temperature reaches certain limits, you know that there is just a short lifetime left. That way you can predict when a failure will happen with a high degree of certainty. Because it's machine learning, and with some of the deep learning technologies, these algorithms improves all the time. So you get more precise, and you tell the customer, in 4 weeks, you are likely to have this failure. Can we please come in 2 weeks and make sure that we change this part so it will not break? We had an example with a customer in Argentina where customs in Argentina is quite complicated. It can take up to 96 hours to import a part that is needed. If you can predict the need of that part a few weeks in advance, those 96 hours doesn't matter. But if you can't predict the need, those 96 hours will cause big losses to food manufacturing. And if you have 50,000 liters of milk in a tank, that will not last for 96 hours if that piece of equipment or that production line cannot run.
You're in many countries around the world, but your experts aren't. So how has digital technology helped you there?
There, one of the areas is mixed reality and how you can connect people. So we use HoloLens, for example, to connect an expert that we might have somewhere in a center, in a technical center, to anywhere in the world through a Skype or similar type of technologies. That makes the expert being virtually present on the factory floor within minutes. So the guy that is in the remote location, he puts on the HoloLens. So the guy that sits with a tablet or a phone, he sees exactly what the local guy sees. They can talk, and he can draw, and he can pull up instructions, he can pull up a lot of things and different types of information that helps the guy that is on site to solve the problem very quickly. We use that in many different parts of the world today, and that adds a lot of value because it's instant support. You can imagine the time it takes to fly someone from one place to another. There is sometimes visa requirements that takes weeks to get, and these type of things. There is other type of applications. So imagine that you're going to build a new factory, and you have this big empty room, and you want to see, where am I going to place my machines? And can I place them in a way so I can open all the doors and these things so it can work in practice? What you do then, you put on a set of HoloLens, you walk around in this big empty factory. So you basically place these virtual machines in the factory, and then you just check that everything works. And then when you have that, you get your drawing, you order everything so it fits perfectly. You avoid these type of problems that there was a wall that you didn't think was there when you check the drawing.
How do you measure the results of the tech that you've incorporated?
Less failures, less consumer complaints on a product, for example, can be an outcome. Financial savings, efficiency improvements, bottom line improvements of our customers and so. The payback for our customers is typically months and not years on these type of investment, because the technology you add is not very costly and the savings can be huge.